Hello, fellow Earthlings. Let's take a look at some equations where we have variables on both sides and solve for them. So you can see here we've got negative 5c and positive 9c. Let's rearrange this to make it easier to see our like terms. We're just going to slide this over here because the commutative property of addition says it doesn't matter what order we add in. So now we can combine these two. Negative 5 plus 9 is equal to 4. Keep that c attached. The left is just staying the same. I haven't done anything to change it yet. So now I've got something that's a little bit less intimidating. I want to get all my variables to one side. I could either subtract 6c or I could subtract 4c. I don't like dealing with negative numbers unless I have to, so let's subtract 4c from both sides. All right, so now this should look very familiar to you, a standard two-step equation. Let's subtract 14 from both sides. Always doing those inverse operations or SADMAG. 14 minus 14 gives us 0. Adding 0 doesn't change the quantity. 4 minus 14 is negative 10. Well, shoot. Looks like I'm going to have negative numbers anyway. That's all right. 2 times c is equal to negative 10. Divide by 2. These become 1. 1c is equal to negative 5. Let's do one more just to really cement it. Negative f plus 2 plus 4f equals 8 minus 3f. So let's rearrange to put our like terms together. And then we've got negative f plus 4f. So negative 1 plus 4 is 3. All right, my next step, let's get all of my variables to one side. I could either subtract 3f from this side and from this side, or add 3f from here, or to here and to here. Doesn't matter, we'll just add 3f because I feel like it. These are additive inverses, so they become 0. So 6f plus 2 equals 8. There we go, a very familiar two-step equation. Do your inverse operations. And divide by 6. And 1f equals 1. Easy peasy lemon squeezy. Let's take a look at a slightly more complicated case. You can see here we've got division. Hey, little bug, get out of here. And we've got some distribution going on. So let's go ahead and distribute our 3. That gives us 6j minus 24 equals 12j plus 4 over 2. This fraction bar acts as a grouping symbol, so that means I have to divide this by 2 and this by 2. So left side stays the same. And then 4 divided by 2 is 2. All right, so now I've got 6j minus 24 equals 6j plus 2. So we could either move all of our j's to one side, or we could start moving these constants. It's up to you guys. Let's go ahead and get rid of this negative 24 because, I don't know, it looked at me funny. Add 24 to both sides. These are additive inverses, so they become 0. So we end up with 6j equals 6j plus 26. So now let's get this j over here. Zero equals 26. Now I don't know where you're from, but where I'm from, 0 isn't equal to 26. So what that means is there's no number that we can plug in to our original equation that will make this true. There's literally nothing j could be that would make this side equal to that side because j has to be the same both times. A really quick and easy way to tell is looking at this step. We have a 6j and a 6j, so they have the same coefficient, but they are adding or subtracting different terms.